the nearest 100,000, how do you go about this? We shouldn't forget the 100,000 is nearest tenth. What did I say you should think about? 10. And what do I say you have to consider? The 0 itself. How many zeros does 10 have? Just 1 0. So if 10 has 1 0, 1 0, 10, which is nearest tenth, can also be known as 1 decimal place. So if I say to the nearest 1,000, how many zeros does 1,000 have? Good day everyone, and welcome to Home Online Maths Education. For many of you who must have watched my previous tutorials and are here right now to watch this live video, I really appreciate. Now you can see we'll be treating approximation, and if you know you have not taken your books, you don't have your pens there with you, then I think that you have to go get it right now, because today's approximations, today's live tutorial is really going to be interesting. So without any waste of time, help me subscribe and click that notification bell. Do not forget to like, because we'll be starting in the next 5 seconds. Okay, now welcome back to Home Online Maths Education. Before we commence, it is normal, it's very important that we take everything to the house of God for perfect understanding. So without any further time, just join me to say this prayer as I say. My mind is where I am always. O Lord, open my mind to easily assimilate today's lesson to the fullest, and help me to become a genius in all my endeavor. So help me God. As easy as that. Okay, let us just drive right into the question we can see today. We have 9,536,278. So how do we approximate a number like this to the nearest tens? It's very easy. This is one thing you must first think about. First of all, think about 10. You are told to approximate or round up this number to the nearest tens. So think about 10. If you are told to approximate or round up this same number to the nearest 100, then think about 100. So to the nearest 10, you're thinking of 10, right? So now, there is another thing you should think about, the 0. So here will be 0. If we say to the nearest 100, 2 zeros, so 2 zeros. If we say to the nearest 1,000, 3 zeros, so here will be 3 zeros. As easy as that. In short, whenever you are told to approximate any whole number to the nearest 10, the 0 is not actually going to begin your rounding up, your rounded up number. Your rounded up number, the 0 is supposed to be at the last, because of how 10 is written, or how 100 is written, or how 1,000 is written. Now, another thing you must take note of is, whenever we are told to approximate to the nearest tens, check the number that becomes 0. If it is up to 5 or more than 5, then that means you have to add 1 to the preceding number. And what is the preceding number? 7. So that means since 8 is up to 5 or more than 5, we'll add 1 to 7 to make it 8. So our approximated work becomes 9,536,280. Now over to the next question. Now this is for 5 significant figures. How do we do this? Now from the word significant, you know that significant means anything important, anything good, anything valuable. So to head straight to the point, if I ask you if 0 is important, what will you tell me? You tell me no, because 0 is simply nothing, and then it means any number from 1 to 9 are our significant figures. So we will check the number that we are seeing right now on the board. We can see that 0 is not here at all. So if you are told to write 5 significant figures, one who is actually paying attention should know that the 5 significant figures accordingly that we are seeing here is 9, 5, 3, 6, and 2. These are what the 5 digits that we can see. So we'll go ahead and do that. 9, 5, 3, 6, 2. we just did 5 significant figures, only that is not the final result. Another thing you should think about is this. Whenever you are told to do 5 significant figures, have it in mind that if the value or the whole number itself that you have been given is a long one, first of all, count out the first 5 significant figures. The rest of the numbers becomes 0. So, which means if you are counting 1, 2, 3, 4, 5, these other numbers should be 0. But another thing you should think of here is that these ones cannot just become 0 like that. Why? Because of what I said the other time. When a particular number is becoming 0, it is very important to check out that number if the number is up to 5 or more than 5. And this number that becomes 0 that I am referring to is usually the first number. Just like this one over here, the first number that became 0 is actually the last one. But in this case, for 5 significant figures, there are up to 2 numbers now that will become 0, which is 7 and 8. And the first number to become that 0 is 7. So since 7 is the first number to become 0, we shouldn't forget that it is 7 we are actually calling here. And 7 is up to 5 or more than 5. So since 7 is up to 5 or more than 5, we are going to add 1 to this. So instead of having 9, 5, 3, 6, 2, we'll clean this 2 and place 9, 5, 3, 6, 3. Then the rest becomes 0. That's how significant figures work. Now to 4 significant figures, we'll still apply exactly the same method. There is no 0 starting this here, so no complications. We'll count 1, 2, 3, 4. So we'll stop at 9,536. 9,536. But that is still not all. We will not end there. Now let's check the first number that is supposed to transform to 0. 2. And 2 is less than 5. So since 2 is less than 5, there is no number adding to 6 to make it become 7. The rest of the number becomes 0, 0, 0. And this is our perfect answer. Now to the nearest thousand. How do we go about this? To solve this, we will still apply exactly the same method that we did for nearest tens. How is 1000 written? 1, 0, 0. So that means we'll locate the last 3 digits. So 1, 2, 3. Now what is the first number to become 0? 2. So is 2 up to 5 or more than 5? Answer that question yourself. Now after answering this question, you have known that 2 is not up to 5. So since 2 is not up to 5, then that means that we have to be writing 9, 5, 3, 6. Then the rest of the digits becomes 0. 6 will not have an extra 1 attached to it because 2 is not up to 5 or more than 5. It is rather less. So if you understand the little I have been explaining since I started the tutorials, I would suggest that you pause this video and comment the answers for this. So meanwhile, let's just dive right into this and solve the remaining question. For whole number, you have nothing to think about over there. The whole number you're seeing is exactly this. Now, as for whole numbers, one thing you must actually never forget is this. That whole numbers don't include decimals or fractions. Even negative numbers like -1, -2, -3, -4, and so on and so forth. So any other thing apart from these other ones can never be a whole number. So in short, whole numbers can be 1, 2, 3, 4, 5, 6, 7 and counting. So if you are seeing a whole number over here and we are told that we should just write out the whole number, we can just pick out this question and put it there. That is our whole number. 9, 5, 3, 6, 2, 7, 8. Now if we're told to do 2 significant figures, what should it be? We shouldn't forget the steps we followed over here on this other side. It is very easy, we can do this. So to 2 significant figures, we'll count the first 2 digits, 9 and 5. So the rest becomes 0. Now let's check the first number that must become 0, which is 3. Is 3 up to 5 or more than 5? No, it's actually less than 5. So since 3 is less than 5, that means we are going to leave our 3 that way. It's going to transform to 0, and then the same thing with the rest of the numbers. So that means now we have 9, 5. Then we'll count the number of digits that are here. They are up to 5. So 1, 2, 3, 4, 5. Now 8 significant figures. We'll count the first 8 digits here. 1, 2, 3, 4, 5, 6, 7. It's not up to 8. So this kind of things is best to leave them void. Now nearest 100,000. So 100,000, how do you write 100,000? You write it this way. So what are we to consider here? These 5 zeros. So that means that the last 5 digits are the ones to become 0. So we count 1, 2, 3, 4, 5. So since these are the ones to become 0, let's check the first number that is transformed to 0, which is 3. Is 3 up to 5 or more than 5? It is none of these. It is actually less than 5. So since it's less than 5, it will just become 0 and it is never going to add any 1 to 5. So that means it remains 9, 5 and 0. Exactly the answer we got for 2 significant figures. So 9, 5 and 5 zeros. Okay, now since we are through with this, hang on for some seconds. We'll be treating another question on the board right now on the same approximation. Okay, over to another question we can see right now. We're told to approximate 243,994,920. So how are we going to be approximating or rounding up a number like this to the nearest tenth? So it is very easy. This question that we are seeing right now is even our answer for nearest tenth. So we'll go ahead and write it. 243994920. Now, why did I say our answer is the result for the nearest tenth? Check this flashback. This is one thing you must first think about. First of all, think about 10. You are told to approximate or round up this number to the nearest tenth. So think about 10. Your rounded up number, the 0 is supposed to be at the last because of how 10 is written. Okay, with all that has been said, let's move over to 5 significant figures. So if we're told to do 5 significant figures, how do we go about this? It's very, very easy. 5 significant figures, what we have to do is count out the first 5 digits that appears in our whole number. So we count 1, 2, 3, 4, 5. So, which is 2, 4, 3, 9, 9. But is that the end of the road? No. So what we are going to do next is this. We are going to check the first number to become 0, which is 4. Next step is this. The rest of the digit becomes 0. Now, since all these numbers become 0, that's not just all we have to do. We should check the first number that is transforming to 0, which is 4. Is 4 up to 5 or more than 5? It is none of those. It's actually less than 5. So since 4 is less than 5, we are not adding 1 to any number. The rest of the numbers become 0 and that's it. So 243990000 up to 4 digits. Now up to 4 significant figures, we will count the first 4 digits. And the first 4 digits are 2, 4, 3, and 9. So 2, 4, 3, and 9. But is that the end of the road? No. The rest of the digits becomes 0. So since the rest of the digits are becoming 0, another thing to look at is the first number that is transforming to 0. Is it up to 5 or less than 5? It is none of those. It is actually more than 5. And since it's more than 5, we'll add 1 to 9 to make it 10. But we cannot just put 10 together. It doesn't work that way. So we are rather going to clean this 9. So instead of writing 10, write 0 and add 1 to 3 to make it 4. As easy as that. Now let's move over to the next. Nearest thousands. Oh, how do we go about nearest thousands? Very, very easy. To move or to go into nearest thousands, what you have to do is count the last 3 digits to see. What we have to do is, first of all, write out our 1000. Now, after writing 1000, it means that we will be locating or we'll be targeting the last 3 digits, which is these ones we can see here, 92 and 0. Now, meaning that these 3 digits are going to transform to 0, although the last number is already 0. So the first number, which is to transform to 0, is it up to 5 or more than 5? It is more than 5, and that number is 9. So that means before 9 becomes 0, it's going to say a very big thank you to Mr. 4 by giving it 1. So giving it 1 now, we have our 2, 4, 3, 9, 9, 5, then triple zeros. Now over to whole number. How do we go about this? What we can see right now is our whole number, so we can just repeat it. 2, 4, 3, 9, 9, 4, 9, 2, 0. Now over to two significant figures. How do we go about this? Two significant figures, we're going to count the first 2 digits that comes in our whole number, and the first 2 digits are 2 and 4. The rest of the digit becomes 0. But one thing is rest assured that you have to think of the first number that becomes 0. And what's that first number? 3. So is 3 up to 5 or more than 5? 3 is none of those. It is actually less than 5. So since 3 is less than 5, it means that we are not adding 1 to any number. We'll just write 24 and the rest of the digits becomes 0. So we'll count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now over to 8 significant figures. We are going to count the first 8 digits that appears in our whole number, which is 1, 2, 3, 4, 5, 6, 7, 8. So, which means, from the scene of things, the last number itself is actually 0. 0 is not going to transform to something else. So, our question is our answer for 8 significant figures. So, 2, 4, 3, 9, 9, 4, 2, 0. Now, nearest 100,000. So, how do we go about this? Very, very easy. If you know the answer for nearest 100,000, don't wait for me to solve this one. I want you to put it right now in the comment section. Pause this video, just 1 minute, and put down your answer in the comment section. If you haven't liked or subscribed, I don't know what you're still waiting for. Do that right now. So over to the nearest 100,000. How do we go about this? It's very, very easy. We will just write our 100,000. 100,000. So what are we focusing on? Our zeros. We have up to 5 zeros. So our target is on the last 5 zeros. So since our target is on the last 5 zeros, we count 1, 2, 3, 4, 5, 6. Oh, just passed. Let's go back. 1, 2, 3, 4, 5. So since we have gotten our 5 zeros, we shouldn't forget that we're still going to check very well the first number that is transforming to 0. And what's our first number transforming to 0? 9. So are we going to write 2, 4, 3, 9, 0, 0, 0, 0, 0, or we are going to write 2, 4, 4, 0, 0, 0, 0, 0, 0. So, for many of you who must have solved this, what do you think the answer should be? Okay, while I'm still waiting, I'll just go ahead and give you the answer. The answer is supposed to be B, and here's my reason. So, this is it for this very question. If you have understood how approximation works right now, please stick around. In the next 10 seconds, you'll be seeing some questions pop up on your screen, and I would want you to copy them as fast as you can and take the next 15 minutes to answer them all. When you are done, please comment all your answers in the comment section, because I'll be there to reveal what you all are doing. So without any further ado, start copying questions. Okay, now that many of you, I don't know if you're still solving, I don't care if you're still solving. Let's just drive right into this. We're not going to sleep here today. Now we have some questions right now on the board. We already treated approximation for whole numbers. Now let's do approximation for decimal places. Now welcome back to Home Online Maths Education. We're not going to do any other intros, we're not doing any other shit. So let's just move into this. Nearest tenth. So how do we go about this? Now as for approximation for decimal numbers, is a little bit different from that of whole numbers. So, but it's still not confusing. If you put your mind into this, you will understand it as I'm talking to you right now. So to the nearest tenth, how do we go about this? You still have to think of 10. You still have to think of 10. Now, how do we write 10? 1 and 0. So now that we have thought of 10 and we've known that our focus is the 0 itself, now let us just drive right into where I want to head to. Now when you see a number like this and you say to the nearest tenth, or you're told to approximate to the nearest 5 decimal place, you don't have to even stress yourself. Every number that comes before the decimal point is not necessary in your count. You only have to start counting all the numbers that came after the decimal point. Easy as that. So don't, even if you see something like 9, 4, 3, 6, 7, 2.10. When you look at something like this, this is just nearest hundreds. All these things are not important when you're counting a particular decimal number to the nearest 10, or maybe to 5 decimal places. Now, another tip for you, nearest tenth is the same thing as 1 decimal place. Why do I say so? When I said nearest tenth, what did I say you should think about? 10. And what do I say you have to consider? The 0 itself. How many zeros does 10 have? Just 1 0. So if 10 has 1 0, 1 0, 10, which is nearest tenth, can also be known as 1 decimal place. So if I say to the nearest 1,000, how many zeros does 1,000 have? 3 zeros. So if 1,000 has 3 zeros, so to decimal places, what should it be? 3 decimal places. Okay, now let's move to the nearest hundredth. If I say to the nearest hundredth, how is 100 written? 1 and 2 zeros, right? So if 100 is written as 1 and 2 zeros, then what is our focus? The 2 zeros itself. So that 2 zeros now, which is our nearest hundredth, can also be known as 2 decimal places. So easy. And do not forget, whenever you are told to do anything like nearest tenths or maybe decimal places stuff, you don't have to consider all the numbers that came before decimal points. No, don't even waste your time to do that. So, without any further ado, let's just move into this. Nearest tenths, the answer is 0.0. No difficulties. As for 5 significant figures, how do we go about this? If you can remember what I said in this video, we can see that 0 is not here at all. So if you're told to write 5 significant figures, one who is actually paying attention should know that the 5 significant figures accordingly that we are saying here is 9, 5, 3, 6, and 2. These are what the 5 digits that we can see. So we'll go ahead and do that. 9, 5, 3, 6, 2. Okay, now you've remembered, you know what I'm trying to say. In this point, the zeros are now commencing first. And these zeros are not going to be important when we are going to count now. Now we have seen the zeros starting first. As for the previous questions, zeros wasn't even starting first. So counting significant figures would be easy. Now that we are going to count 5 significant figures, don't waste your time counting these zeros. But please, put your zeros down. But we are going to count 5 significant figures. So these are not important. We'll just start counting from here. 1, 2, 3, 4, 5. So it stops at 6. So 5 significant figures is 0.0035 976. 2 disappears. So 4 significant figures, if you understand how I explain these 4 significant figures, should be able to do 4 significant figures right now. So without any further ado, let's just do it. 4 significant figures, the zeros are not necessary over here, so we'll just count. 1, 2, 3, 4, which is 0.003597. But it's not the end of the road. Oh, thank you for reminding me. Yes, for many of you might be confused that no, asking me some questions. This is not the end of the road. Why? Because we can see that the first number that is actually going to disappear, which is 6, has the qualities we are looking for. It is up to 5 or more than 5. So since it's up to 5 or more than 5, we have to add 1 to 7 to make it 8. So instead of putting this intruder in our midst, we eliminate it and put 8, the rightful king. Now let's move over to nearest thousand. For the nearest thousand, do not forget what I explained about nearest thousands and nearest tens. All the numbers or all the digits that comes before the decimal point are not necessary in our counting at all. So nearest thousands, how do we write 1000? Can somebody help me? Oh, yes, thank you. Nearest thousand, 1000. So since we can remember that 1000 is written as 1000, then that means if I am told to write nearest thousand, I am supposed to consider 3 digits after the decimal point. So what are those 3 digits? 0, 0, and 3. Now we shouldn't forget, before I write 3, 5 is up to 5. It is not yet more than 5, so it's just 5. We're just going to add 1 to 3 to make it 4. So that means for nearest thousand, we'll be getting 0.004. Now to a whole number, very easy. Hey, don't stress yourself, just write 0. For some of you who are still shocked, why 0 is the number? Don't forget, the whole numbers hate anything decimal numbers or fraction or negative numbers. Those things are nonsense. What whole number really love are perfect numbers. 0 is one of them. 1, 2, 3, and so on and so forth. So here we have our 0. And another thing we should think about is this. If the next number after the decimal point is up to 5 or more than 5, our answer should have been 1. Why 1? For instance, let's say it is 0.9 blah 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 blah. 9 is up to 5 or more than 5, so we'll add 1 to 0 to make it 1. I'm sure you understand now. Thank you. Now over to 2 significant figures. All the zeros there. Don't waste your time. 1, 2. So are we going to write 0.0035, or we are going to write something else? I think we are going to write 0.036. Yes, that's what it should be. Why? Because the next number after 5 is up to 5 or more than 5. So we add 1 to 5 to make it 6. So instead of wasting our time, our precious time, writing 0.0035, we'll just write 0.0036. 0.0036. Now, over to 8 significant figures. How do you go about this? 8 significant figures. We're just going to count all the 8 valuable number in our question. And from the scene of things, it's not going to reach. Let's try it out. Not important. 1, 2, 3, 4, 5, 6. My hands are off. Void. It's not there. Now to the nearest 100,000, how do you go about this? We shouldn't forget the 100,000 is it's written as yes, thank you. That's 100,000. It's written that way. So what's our concentration? 5 zeros, meaning 5 digits after the decimal point. So we're going to count 1, 2, 3, 4, 5. Stopping here. So, are we supposed to write 0.0359? I don't think so. I think it's 0.05. Stop it, you idiot! How can you write this? How? Tell me how. Give me some reasons, some tangible reasons why you should do this. No, it doesn't work out that way. It doesn't, please. So try to focus. Try to focus. We can't write this. Why can't we write this? We are checking the first number to disappear. You know, we shouldn't forget that since we are writing to the nearest 100,000, we know that the remaining numbers are disappearing, they're just vanishing away. So before we just let the numbers go, let's check out the first number that is transforming, that is actually vanishing away. And what's that number? 7. 7 is the first number to vanish away, and it is a number that is up to 5 or more than 5. Since 7 is up to 5 or more than 5, that means we're going to add 1 to 9. And adding 1 to 9 makes it 10. But please don't do this. This is a suicide mission. How can you write 3510? No. So I'm cleaning this trash and just move on to the exact one that's supposed to be. So the 100,000, I'm sure you should have understood right now. So put down your comments in the comment section. Don't waste time. So to 100,000, what should the answer be? Let's look at first 5 zeros, or first 5 digits rather. 1, 2, 3, 4, 5. So instead of writing 359, 7 is up to 5 or more than. So we'll add 1 to 9 to make it 10. So, but instead of writing the 10, it's shaking the world. So we're going to put 0 and add 1 to 5 to make it 6. So answer becomes 0.00360. As good as that, or as good as new. Now over to 5 decimal places. 5 decimal places. 5 decimal places, no big deal. Just count the first 5 digits. Okay, we're writing 0.0359, but the rest of the numbers are vanishing away. Now, what's the first number to vanish? 7. So since 7 is the first number to vanish, we are going to add 1 to 9 to make it 10, and then instead of writing 10, we write 0 and add 1 to 5. And we're getting exactly this. We shouldn't forget our 0 is very important, please. Do not just do this and throw away your 0. You end up writing another thing else. Please. For many of you who might be doing something like that. So this is our answer, 0.00360. 4 decimal places. We'll count 1, 2, 3, 4. And now 9 is up to 5 or more than 5. So add 1 to 5 to make it 6. So that is 0.0036. So for many of you who would have written 0.036 as your nearest 100,000, now you see that if you had written that, you are even writing the answer for 4 decimal places, which means that when any teacher who gives a question like this sees something like that, he's going to mark it wrong because you are giving an answer for another question. So you have to be very careful about this. So for 8 decimal places, let's see, 8 decimal places and 8 significant figures, if they are the same. If they are the same, please comment in the comment section. Let me know whether you are even following up at all. To be honest with you, I'm sure many of you are really understanding me, and I'm sure that you are going to make your teachers proud one day. So I really don't want to preach, I really don't want to go too deep, but one thing that you must understand is this: the 8 decimal places and 8 significant figures ain't the same thing. They are not the same thing. 8 decimal places, all the numbers, it doesn't matter whether it's 0, it's not 0. All the numbers after the decimal points are going to be counted. But if it is for significant figures, if the numbers after the decimal point are zeros, just like this ones, then that means you are not going to count them. You can see our answer for void for 8 significant figures. It is this because we never counted any of this. We started counting from here, which actually stopped at 6 significant figures. It didn't go higher than that. So for 8 decimal places, how do we go about it? We start counting from the first digits that appear after the decimal point, which is 1, 2, 3, 4, 5, 6, 7, 8. Voila, we've just gotten it. We've just got it. We've just got it. We've just gotten it. 0.00359762. Oh, that is just it. I'm getting tired. No, you are a soldier. You are a good guy. You are a good girl. You are good. You want to be first in class. You want to do well. So you can't be tired. You are going to follow up. Let's move up to another question. Oh, now we are back with another question. My legs ache a lot. Oh, why are my legs aching? I'm a soldier. Why should I be tired? So now let's move on to this beautiful question that we can see right now on the board. So easy, so easy, so easy. Okay, now nearest steps. It's so easy, so easy. How do we go about this? Don't forget, if you are approximating or rounding up or yes, if you're rounding up, if you're approximating, if you are, forget the word. If you're rounding up a particular number, a decimal number for that matter, to the nearest tenth, how do we go about it? Don't forget that the first thing you should think about is 10. So since we are thinking of 10, what is the first, what is our main focus here? The 0 itself. And how many 0 can we see in 10? Just 1 0. So since we are saying 1 0 in 10, then that means that we are just going to concentrate only on one digit after the decimal point. So our answer is supposed to be 94.3. What? 0? Oh, thank you. Thank you for telling me. Thank you. Thank you. I almost forgot. Yes, it's not 94.3. How can it be 94.3 when 6, the next number that vanishes away together with the rest, the first number that vanishes away is up to 5 or more than 5. We have to add 1 to 3 to make it 4. So 94.4 is the correct answer. So 5 significant figures. How do you go about it? Now in this case, there is no 0 starting, no shade. So we're just going to move ahead. You count first 5 digits. 1, 2, 3, 4, 5. Now the first number to disappear is what? Answer that to the comment section. 2 is the first number to disappear. So since 2 is the first number to vanish, then that means we should look at it. Is 2 up to 5 or more than 5? No. 2 is actually less than 5. So since 2 is less than 5, we'll let it just vanish together with its siblings. So that means if we are told to write the 5 significant figures, we'll just count the first 5 digits and put it down there. And then we have 94.360. Sorry for the point. Now to 4 significant figures. Now, how do you go about the 4 significant figures? We'll still apply exactly the same method that we did for 5 significant figures. So we just count 1, 2, 3, 4, and then we're supposed to write 94.36. Why? 0, which is the first number to vanish, is not up to 5. It is nowhere close to 5. It's less than 5 big time. So the rest of the numbers become 0. Now we have 94.36. Now to the nearest thousands. If you can remember what I said about nearest thousands, then put your answer right now in the comment section. This time and I'm going to wait for 10 seconds. Let me see those that will put the answers. Yes, keep on putting your answers. I'm seeing you. Go ahead. Okay, for many of you who are still shocked, you don't know what the answer is. Although I believe you all already know the answer. Probably some of you don't feel like commenting. There's no problem. Let's just move into this thing. For nearest thousands, how to go about this is every number that comes after the decimal point is the thing to count. So every number that comes before the decimal point is not in any way necessary in your counting. No matter the number at all, no matter the digit at all. So since we're talking about nearest thousands, how is 1000 written? 1 and 3 zeros. So which means we're expecting to count only 3 digits after the decimal point. And what are those 3 digits after the decimal point? 360. So that means that the answer we got for 5 significant figures is going to be the answer for nearest thousand. So 94.360. So to whole number, very easy. Our answer is 94. Probably if the number after the decimal point is up to 5 or more than 5, then that means that we could still add 1 to 4 to make it 95, while the rest of the number disappear the way it is over here. So now over to 2 significant figures. How do you go about this? The answer is 94. How is it 94? It's 94 because we are only counting 2 digits, right? That's 2 significant figures. They didn't say 3. If we were asked 3 significant figures, we would have counted 1, 2, 3. But don't forget, your answer can be 94.3 because of the 6. So, but that's by the way, you're talking of 2 significant figures. We only count 1, 2, 1, 2, which is 9 and 4. We'll stop there. 94 is our answer. 3 is not up to 5. Now, 8 significant figures we count. 1, 2, 3, 4, 5, 6, 7, 8. Now, since the 8 significant figures is stopping at 5, are we going to just write and stop at 5 and end it that way? I don't know. For many of you who knows what the answer is, I think I'm forgetting some things. I don't know. Divine wisdom. Now, the truth is this. It doesn't have to be that way. What you have to think is just go ahead and put down your answer, because the first number to vanish, which is 1, is not up to 5 or more than 5. It's not anywhere close to 5. So since it's not close to 5, so that means that our answer should be 94.360205. So to the nearest
100,000.
How do you go about it? We are going to count. Before we start counting anything, how do you write 100,000? Like this. So now our concentration is on the zeros. And how many zeros can we see there?
5 zeros.
So since we can see 5 zeros over here, then that means our concentration, or where our mind should be, is on all the digits that came after the decimal point. We are not transforming all those digits to zeros, so no, don't take me wrong. All the digits after the decimal point are our focus. So the rest of the digits that exist over there after the decimal point are not going to be necessary anymore. So we count 1, 2, 3, 4, 5. So the fifth one is the last zero itself. So since 0 the last 0 is the 5th digit. Are we just going to stop at 0? No. The first number to vanish, which is 5, is up to 5. Although it's not more than 5, but it's up to 5. So it has made it our standard. Then what we have to do is add 1 to 0 to make it 1. So since 1 has been added and now it is 1, our answer becomes 94.36021. Now to 5 decimal places, the answer for the nearest 100,000 will also be the answer for 5 decimal places. I can hear you. Don't worry. I can hear you shouting it out loud that is what the answer is. So don't bother. I can hear you out loud. So that means we'll just repeat exactly this. Now, as for 4 decimal places, we're not going to repeat the same thing because 5 decimal places and 4 decimal places simply not the same thing. So since it's not the same thing, what we are going to do now is what? Count the first 4 digits after
the decimal point.
So if that's what we're going to do, we count 1, 2, 3, 4. So which is 3,602. So since we are going to write the 3,602, we shouldn't forget that we're not throwing 94 away. We are actually going to put it in our answer, which is supposed to be 94.3602. It is wrong to call it 94.3602. Take note. Okay, over to the last question that we have on the board. Let's just move into this thing. So 8 decimal places, how do we go about it? To solve for 8 decimal places will not be a difficulty. It's just very easy. We just count the digits after the decimal point. Every other digit that came before the decimal point is not necessary in our counting. So 1, 2, 3, 4, 5, 6, 7, 8. Did I count very well? 1, 2, 3, 4, 5, 6, 7, 8. So that means the question we are seeing on the board is actually our answer. What are we waiting for? Let's put it down. Yes, we've just finished and completed our mission. Okay, now this is all. No more dramas. I'm tired of all the drama. So now we are through with approximation for the day. We've treated significant figures, decimal places, whole numbers, nearest tens, nearest 100, nearest thousand, nearest thousandths, and so on and so forth. We've just done everything. Probably if I had said you should write this to the nearest million, I hope you can do that. Okay, that's one thing you should do for me right now. Put it now in the comment section. I'm watching you all. If you got it, I'm going to give you the thumbs up right now. So be waiting for me to give you the thumbs up. I'm not wasting any time. And don't forget, I'm also going to give you a heart. Yeah, go ahead, put your answers. If you didn't receive any hearts, if you didn't receive any likes, then that means you didn't get your answer correct. So that is just it for now. We are through with this very topic. But in order to be 100% sure that you will now know how to do this, I think you have to like this video if you haven't. Then click that subscribe button over there. Hit the notification bell. It helps a lot. So thank you for watching. Check out these questions that you're about to see right now. I'm giving you just 15 minutes to answer the question. Don't even try to waste time, because if you waste time, I'm sending you back to where you're coming from. I'm joking. So thank you all for watching. Remain blessed. Next time we'll go live together and we'll learn together. We'll improve together on mathematics. Meanwhile, if you want to follow me up and you want to get in touch, check out this contact you're seeing right now on the screen, and then I can always add you up to my WhatsApp group where I get everybody engaged every Wednesdays and Saturdays and Sundays. And apart from that too, I also have my Facebook group known as Home Online Maths Education. You can follow me up on Instagram. That's the name of it, Official Teacher M. So thank you all for your love. I'll be seeing you next time. you.